Welcome to Domain and Range Part 2. Alright, in this example, in this video, we're going to look at a few more complex examples and specifically talk about restrictions on the domain. For instance, if you have a function, let's say y equals square root of x, you know that you cannot have negative numbers in here. Therefore, because of that, the lowest value we're allowed to have underneath a radical is 0. So if we want to think of it in terms of domain, we look at it as x is greater than or equal to 0, or we can look at it as x is, we could look at it here, like this in interval notation. That would be the domain, because that's as far as it will go. Okay? So the next thing we're going to do here is look at another type of restriction. And that is when you have something like this. And these are very simplistic cases. But here we need to know that radicals, actually we should not say radicals, we should say square roots, have restrictions. Okay? Square roots have restrictions. Okay? But we also have this guy here, which is a fraction or a rational function. And here we know that x cannot equal 0. All right? We know that. Guess what the domain is? Guess what? This is the domain. Okay? Actually, in interval notation, we would write that negative infinity comma 0. All right. And then we would click, let's see here, 0 comma infinity. Okay. Now this is also, so we say this also is a restriction when you have a denominator. So we say restrictions also occur when fractions happen. So fractions have restrictions. We need to look for those restrictions when we are talking about the domain. Okay, so let's look at a couple of examples dealing with this very thing. Okay, for instance, we could say, what's the domain of y equals the square root of x minus 5? Well, to figure that out, what we do is we simply take the radicand, what is underneath here, and set it greater than or equal to 0, because you know whatever is under here has to be greater than or equal to 0. And solve. And that actually gives us our domain. Okay? There it is. It's that simple. In terms of interval notation, it would be this. Okay? We could also try a second one of the same nature, like this. We'll reverse it. Okay? And then you just say 5 minus x is greater than or equal to 0. And then, of course, you solve, and you end up with getting x less than or equal to 5. All right, so this would be negative infinity. Ooh, that's pretty bad, isn't it? To 5 would be your domain. But what if we have a fraction then? Let's say we have x over x minus 4. Okay? Well, the rule for this one, instead of setting it greater than or equal to 0, we know that this guy cannot equal 0. So that's exactly what we do. We take the denominator and set it not equal to 0. All right? And so we say x not equal 4. And that's our domain. Believe it or not, that's what it is. So we can also write this, of course, in interval notation, negative infinity to 4, and then 4 to positive infinity. You might want to include a little or statement in between there. All right, but what if we had something a little more complex, like x squared plus 2 over x squared minus 9? Well, it's the same exact thing. It's just x squared minus 9 is not equal to 0. And if you solve this correctly, you know that x cannot equal plus or minus 3. All right? And that's it for this particular video. What we're going to do in our next one, in part 3, is we're actually going to combine radicals and fractions.